So in this video, I am covering 16 questions. A very easy paper. Two particles having masses 4 grams, 20 grams have same kinetic energy. Any particle is moving with a velocity v. Its kinetic energy of a particle is half mv square. What he is asking is ratio of momentum. We can write which is mass into velocity is moment. So here P square is 2m into k. Same kinetic energy. That means kinetic energy is fixed. P square only proportional to m. So ratio of their momentum means P1 square by P2 square, which is equal to m1 by m2. 4 by 25 is 2 by 5. So first option is correct. Here 1000 kg block is moving with a velocity on a smooth surface with a velocity 6 meters per second. Suddenly, a block of mass 200 kg is placed on this. So it is a sudden change. We can say momentum is conserved. So initially 1000 kg is moving with a velocity. This is momentum before placing 200 kg mass, momentum after placing 200 kg. They may move with a velocity, some other velocity, which is 1200 v dash. So v dash is 5 meters per second. Here a wire of length L resistance is divided into 5 segments. Once line here, wire is broken into 5 parts. How resistance changes means, so once you take a wire, you cut like this, there is no change in cross-sectional area. Since same wire you are using, resistivity and cross-sectional will be same. So resistance is proportional to length. Once you divide into 5 segments, so each segment, length of each segment is L by 5. Since R is proportional, so resistance of each wire becomes R by 5. When N resistors are connected in parallel, effective resistance is nothing but R by N. So here it is R by 5. Like this, 5 resistors are connected. Effective resistance will be R by 25. So your acceleration due to Earth on the surface, that is gm by r square. If the mass of the Earth remains the same, radius is half. That is, mass remains same, radius is half. It is 4 gm by r square, which is 4 g naught. Here, particle is moving with the initial speed. What did this vector represent? Meaning horizontal speed is 5 meters per second. This is the initial horizontal. Initial vertical speed is this, and constant acceleration. So acceleration in x direction is 2 meter per second square. Here acceleration in vertical direction is start from the origin. After some time, it is observed that it is moved by 84 meters along x-axis. Along x-axis, distance covered is 84 meters. You have to take only horizontal components. Yes, here is 84. Horizontal speed initial 5. Time we don't know. Horizontal acceleration 2 t square. So here t square plus 5t is equal to 84. 12 sevens. Here you get t minus 70. Time can't be negative. So in 7 seconds, it travels a distance 84 meters. Here he is asking final speed. Final speed means speed when it reaches 84 meters, horizontal direction ux plus axt. U here initially 5 meter, acceleration in horizontal direction is this time. So it's 19 meter per second. Vy, uy plus ayt. Uy in vertical direction, its speed is 2. 3 time taken, 14, 21 plus 23 meter. So here V will be Vxi plus, that is 19i plus 23 J. Here a beaker is filled with 2 liquids, each of height 6 meters. So here coin is kept at the bottom of the container. Suppose if you consider one liquid of height 6 meters, coin is placed here. So coin is in denser medium, observer is in rarer medium. In a normal view, so person is observed from rarer medium, object appears to be very nearer. This is called apparent depth, not real depth. It appears to be nearer, that is h by mu. Original height is this 8 by 3. So 18 by 8, 2.25 meters. So if some other liquid, if you consider again up to 6 meters height, because of that depth, same height they consider because each of height 6 meters, but here refractive index changes, different liquid 5 by 3, 18 by 5, 15. So final apparent depth will be 2.25 plus 3.6, 5.85 centimeters. Here, radius of electron in third stationary orbit. So the relation between radius and right orbit is Rn is equal to, Rn is proportional to n square. R1 by R2 is N1 square by N2 square. In third orbit, its radius is r. In fourth orbit, what will be the radius means? So R2 will be 16 r by 9. Here, a rectangular loop of length present here, rectangular loop is placed in a magnetic field of 4 Tesla, making an angle 60 degrees with the plane of the loop. Here, before discussing this problem, I will discuss about what is angle between plane and line. So it is plane, it is a line. Angle between plane and line is theta. Angle between normal and line will be 90 minus theta. Here you have a rectangular loop 2.5 meter, dimensions 2 meters, is present in a magnetic field making an angle 60 degrees with the plane. So 60 degrees with the plane means in general we have to take like this. But this we are not getting the answer option. So it should be maybe the data which we collected or given question may be wrong. Here it is 60 degrees. It's not with 60 degree, not with the plane, with the normal of the plane magnetic field. So this is the area vector, right? So area vector will be always perpendicular to the surface. So in this case, first loop is pulled out. Find the EMF induced. So EMF induced is equal to minus d phi by dt minus p final, pi final minus pi initial. When it is pulled out, loop is pulled out, flux will be zero. Then here EMF induced will be only the time interval he told. When there is a change in flux, the EMF field will be induced. So now we have to calculate flux when it is kept in a magnetic field. So between magnetic field and area, it is BA cos theta. Area is 2.5 into 2 cos 60. Cos 60 half. This is 10. And EMF induced is 10 by 10. We get 1 volt. So here the angle must be with the normal of the plane, not with the plane. Here magnetic field between so two wires which carrying current in opposite direction. So here current flows in upward direction, here downward direction. So where we have to find in between parallel wires, let us say somewhere else. This distance is 5 centimeters. What he given is 5 centimeters. You have to find magnetic field at P. Magnetic field at P will be magnetic field at P due to first wire, magnetic field at P due to second wire. If direction of magnetic field. If current, put thumb in the direction of current, your magnetic field will be inwards. So magnetic field due to infinite wire carrying current I, formula we have mu naught I by 2D current I at d distance, which is 2 pi d. Right. Here also magnetic field due to so another wire which carrying current. So here also that will be inwards. Put thumb in the direction, finger shows that magnetic field will be inward direction. Numerically this much, both uh, due to both the wires which carrying current, magnetic field will be in the same direction. I can add numerically mu naught I by 2 pi d plus mu naught I by 2 pi inwards. That is mu naught I by pi d inwards. Since he is asking only magnitude, so without direction we can mu naught is 4 pi into I here is current 10 amperes. Distance will be how much? This is distance pi by 2. So here it is 5 to 16 into 10 power minus 7 or 1.6 into 10 power minus 6. Oh, sorry. So here it is centimeters also given. Distance is in centimeters by 100. So then we can write here into 100. 16 into 10 power minus 5 or 160 into 10 power minus 6. 160 micro. 4 objects of mass 1 kg are placed at the vertices of a square of side 2 meters. An axis passing perpendicular to the plane of the wire through one of the vertices. This is axis. Then calculate moment of inertia. So here total moment of inertia. If axis passing through this mass, there is no moment of inertia because r is 0 about this particular point. So moment of inertia of this mass about this point. Moment of inertia of mass present at B with respect to this point. Moment of inertia due to mass present at C due to with respect to the point, which is mr. R is this 2 square. Again due to this 1 into 1 square, but sorry 2 square. This is 2, it is 2, it will be 2 root 2. 4 plus 8 plus 4, 16 kg meters. Here specific mass of a body he given 0.08 kg. Specific heat he given 0.17 kilocalorie per kg. So calorie is CGS unit. You should be very careful about the units. All must be in same system. 1 calorie approximately this. The temperature difference is 5 degrees. Find a change in internal energy. So change in internal energy is ms delta T. So here it is 0.08, 0.17 kilo 10 cube calorie 4.18, temperature is 5 degrees. 0.08 into 10 cube, that is 8 into 5. So one more 10 is left over. So 1.7 into 4.18. 40 into 1.7, 68 into 4.18. Roughly 200, 240 plus 32, it is nearer to this 284 joules. So the displacement he given it as is asking velocity at t equal to 1 means instantaneous velocity, which we can get by differentiating. So it is 4i. So here, this one is a conceptual question. A proton with constant velocity passes through region of a space without any change in its velocity. A and B represents electric and magnetic field. So here, when both electric and magnetic field is there, so let us assume here electric field and magnetic field both are present. If a charged particle moves in combined field, combined means here both electric and magnetic field, force on this will be, it's a Lorentz force V cross P. Let us see, when electric field is 0, this is force due to electric field. This is force due to magnetic field. When electric and magnetic field are 0, force will be 0. That means no change in velocity. So this is possible. When E 0, second option B not equal to 0, then only magnetic field presence. This also, if force is 0, there won't be any effect on the charged particle. When V is parallel to B, V cross B will be 0. Force will be 0. So still in this case also there is a possibility that force is 0, no change in velocity. There is a possibility. Third option, if you consider C, electric field is not 0, magnetic field is 0, then force will be only QE. So there is definitely force on charged particle because of electric field. There is change in velocity. So in C, velocity definitely change because there will be a force. Last case, when E is not 0, B is not 0, or then there is one possibility when their magnetic field and suppose here is Electric field, which is in downward direction. Magnetic field, I will take inwards. So that is in minus k direction. This is magnetic field direction. Charged particle is moving along x-axis, let us say. Then net force will be QE plus QV cross B. E in the sense here minus QEJ. V means particle is moving in I direction. Magnetic field is in minus K. QVB I cross minus K will be plus J. In case QE happens to be QVB, net force will be 0. Then there is no change in velocity. So if both are not 0 also, there is a possibility that that particle is not affected by both the fields. There is a possibility. So first option is correct. Here an object is released from the point A. Distance between B and C. This diagram also might have given 80 meters. And it took 2 seconds to reach. Initially, when he releases a particle, at this point it has a velocity. At this point, its velocity is, let us say, v. So now it covered 80 meters in 2 seconds. S equal to ut plus half at square. So it is moving under the influence of gravity. At this point, velocity we don't know. Let me write Vt. Half acceleration is gt square. S he given this. Time also he given. G is known value. So 2v is equal to 80 minus 20, 60. So velocity here is 30 meters per second. So distance from A to C he is asking. So how much time it took to fall from A to B? V equal to U plus 8. U 0. Acceleration is G, which implies time is 3 seconds. So AB will be UT plus half GT squared. Initially it released U 0. G is 10. 9. That is 45 meters. So AC becomes 80 plus 45, 125 meters. Here particle is undergoing SHM having maximum velocity. Any particle which is executing SHM, its velocity is this. V maximum is obtained at x equal to 0. V equal to d omega. And amplitude, he given it as 4 centimeters. From this, maximum velocity he given, the amplitude he given, I can calculate omega to radian per second. Find the distance of the particle from mean position when velocity is same formula we write. He is asking V here is how much he given? 5 centimeter per second. Amplitude is fixed, that is 16 minus x square. which implies 16 minus x square under root is 2. X square is 12, which implies x will be 2 root 3 centimeters. So electric field is given. So wave is propagating in x direction. Then find its intensity of electromagnetic field. Intensity of EM wave is equal to half epsilon naught c. So don't write c as velocity of light directly as 3 into. Sometimes it may be correct. We don't know the medium. So you better write v equal to omega by k. Here, question must be, so 200 sine omega and k. Omega here is k value 0.05. That is 0.3 times, right, 30 times. That is 3. Luckily, we got velocity of. Sometimes it may differ if medium differs. So intensity half epsilon naught 8.85 into 10 power minus 12. So the amplitude of electric field 200 square. So 3 into 10 power 8. So this 4 into 3, 12. 12 by 2, 6 into 8.85. 10 power minus 12. It is 10 power 4 into 10 power 8. All get cancelled. It's 53 point. Yes. This is small correction in the video. So here it is micro Tesla. So unit I wrote wrongly, micro Tesla.